Okay, we start with this expression. Of course, the caret third means this quantity raised to the third power. The caret 4 means x is raised to the fourth power. And the slash means division. So we translate into standard notation. Get this. And then what do? Well, people were pretty much right on this. Said, well, we raise all this to the third power. Exponentiation distributes over multiplication, basically. So we have 3 cubed multiplied by x squared cubed. And that, of course, divided by x to the fourth. 3 cubed is 27, easily calculated. X squared cubed, well, we multiply exponents. And I'll talk down here about why we do that, just to make sure we have a good picture of the consistency of the laws. X squared cubed is x to the 6th. We multiply the exponents. 2 times 3 is 6. And then we have x to the 4th here. Now there's another rule that says we subtract exponents if we're dividing. Well, dividing x to 6 by x to the 4th, if we just do that, subtracting exponents, we get 27x to the 6 minus 4, which is 27x squared. But why should that work? Well, that works simply because x to the 5th can be written as x squared times x to the 4th. Now, why would I write it that way? Well, because I want to match up an x to the 4th here with an x to the 4th here. Having matched up the x to the 4th terms, those divide out to give us 1. So we just have 27x squared. So it's 27x squared times x to the 4th over x to the 4th. And that's just 27x squared times 1, which is 27x squared. And implicit here is the fact that you can always subtract exponents. You can always factor out whichever exponent is smaller between this term and this term, and then divide it out and leave the remaining part. So here, where we factored out the x to the 4th and divided here to get x squared, we could do that every time. Sometimes you got a higher exponent in the denominator than you've got in the numerator, but then you're going to have to factor out the denominator, and the numerator will divide out, leaving you a power in the denominator. Okay, there's nothing too mysterious about any of these rules. Now let's back up to the reason you multiply exponents. X squared cubed means what? Well, x squared means x times x. Cubing x squared means you're going to multiply x by itself 3 times. And of course, that gives you x to the 6th. And let's see, not all of my multiplication signs look like multiplication signs. Let's make sure we're reading these all correctly, because it's real easy to read that sign as an X if it's not made fairly clearly. Okay, so that's basically it. That's the reason you multiply exponents, and you can apply that to any power of any power. Of course, when you extend that to fractional powers, you got to do it a little bit on faith. It can be proven, but not at the level of this course. Okay, then we simplify a couple more. The square root of 3 squared plus negative 4 quantity squared. Very straightforward. 3 squared plus the square of negative 4 is 9. Square root of 9 plus 16. 9 and 16 is 25. The square root of 25 is 5. And I don't think anybody is going to have any problem with problems of this nature, any difficulty with problems of this nature. Okay, another expression. And we write it in standard notation. So, what do we have to do? Well, the first thing we need to do here, we have a quantity cubed in the denominator, and we distribute the cube over the multiplication. We get 2 cubed times x to the negative 2 cubed times y squared cubed. Then we cube those terms, or factors. We get 2 to the 3rd is 8. X to the negative 2 raised to the 3rd is x to the negative 6, because you can multiply exponents. Y squared cubed is y to the 6th, again multiplying the exponents. Then we simplify this. Okay, well, 2 over 8 leaves us a 4 in the denominator, and things are kind of running together here. Let's make sure we put a line between, not much of a line, whatever that is, a boundary. Okay, we have now x squared over x to the negative 6th. How do we simplify that? Well, when we divide, we can subtract denominators. Now, we could alternatively have written x to the negative 6th as 1 over x to the 6th, and then use the rule for complex fractions and flip that and ended up with an x to the 6th in the numerator. But right now, we'll just use the simpler approach. X squared over x to the negative 6 is x to the 2 minus negative 6. Not x to the 2 minus 6, but x minus negative 6, because we're subtracting the negative 6. Okay? And then y to the negative 3 minus 6. That gives us x to the 8th, y to the negative 9th in the numerator, 4 still there in the denominator. And since y to the negative 9th is 1 over y to the 9th, we can write the result as x to the 8th over 4y to the 9th.